Ponchon and Savarit Method. This method was developed in 1921-1922. Ponchon and Savarit Method is similar to the McCabe-Thiele method, but it involves material and energy balance equations as well as equilibrium relation. So, both the McCabe-Thiele method and the Ponchon Savarit method are the most common methods used for the graphical analysis of distillation processes. So, basically, these two methods help us determine how many theoretical stages or trays we need to separate a binary mixture in a distillation column. But Ponchon Savarit method is used for multi-component distillation systems, especially when dealing with non-ideal mixtures, azeotropes, or when energy considerations are important. Hence, Ponchon Savarit method can be used for multi-component distillation systems, which show non-idealities, such as deviations from Rawls' law, azeotropes, and multi-component systems which show more complex thermodynamic behavior. It is the more rigorous method, and is free from the assumption of constant molar overflow. So, as in McCabe-Thiele's method of design of the distillation column, we assumed equimolar overflow. Therefore, in McCabe-Thiele method, we combine the material balance and the equilibrium relation to create the diagram and determine the number of ideal stages needed for a specific separation through graphical analysis. However, it's important to note that the flow of vapor and liquid within a distillation column depends on the enthalpies of the mixture. Hence, to remove this assumption, in Ponchon and Savarit method we must consider the material and energy balance equation, along with the equilibrium relation to construct the diagram, and find out graphically the number of ideal stages required for a particular separation. That's why, the Ponchon and Savarit method is a more complex and time-consuming method than the McCabe-Thiele method, because it requires more data, such as enthalpy values. Hence, to design and analyze the distillation column graphically, in the Ponchon and Savarit method we use two separate diagrams. The first one is the enthalpy diagram for energy balances, which helps to calculate heat duties and the thermodynamic relationships in multi-component systems. And another is the composition diagram for liquid and vapor phases. So, in this Ponchon Savarit method, we use these two diagrams and then stepping off stages through both compositions and enthalpy curves, and finally, we can estimate the number of stages and energy requirements.